Well, I've cleaned up the case. I've taken the banana binding post knobs off, and the 3 knobs, one for the switch, 2 for the trim capacitors or adjustable capacitors, and those are going to get soaked and scrubbed in the morning. I've already cleaned up the faceplate, tightened and readjusted all the hardware, cleaned it up pretty good, and although everything on the back looked like it was in good condition, the original solder jobs were just terrible, atrocious. They did all seem to have good continuity. I probed around and it would have worked, but I sucked all the solder off, cleaned up the connections, and resoldered it. And put some deoxide on the switch. And I think that's about as good as it could possibly be at this point. The front panel's not too bad. It's a little blotchy, but that's true with any of these old Heathkits from this period. Even if they didn't get used very much, the paint suffers from age. I've got the knobs, banana posts, screws, etc. soaking in warm soapy water. Then I'll go over them with a toothbrush. This knob's recessed pointer line, I don't know what the proper word is, had mostly lost its white paint, so I masked it with Scotch tape and put on some, probably about a 30-year-old bottle of Tester's Model Master Classic white paint, which seemed about the right color, and that seems to have come out pretty good. Alright, it seems that the diode in this CR-1 was faulty, so I connected up the same one I used on my antique radio. You can hear a little bit, very faint. Let me see if I can dial it in. Well, with the CR-1 connected with the earphone, I'm able to pick up a few really weak stations, just barely audible and hard to understand what's being said. Although the selectivity is pretty good, it's not like I'm getting multiple stations. But that may be just because it's now the middle of the day. When I was testing the other radio, it was earlier in the morning. I know that atmospheric conditions can change reception on a crystal set rather dramatically. So probably would be better if I just left this setup and tried coming back and trying it out tonight and seeing if I could get better results. But it is working. Now, between when I first connected this up, I found 2 problems. First off, the diode that was in here, when I disconnected it and put it on my tester, it had a forward voltage of about 0.75 volts, which is really high, I think. So I soldered in a 1N34A, and that's when I started to get some listenable results, or at least detectable results, in the earphone. The other thing I found is that, let's see, which way is it? Yeah, the phones, or the detector capacitor was shorting out in some positions of its rotation. One of the plates had been bent a little bit, so I took it back up to my lab and painstakingly straightened it out until I could rotate through the whole range and not detect any short circuits with a continuity detector between one set of plates and the other. So I believe that that's okay, although it may be a little compromised still, even if it's not actually shorting out. It may throw its capacitance off substantially, making tuning more difficult. But at least the circuit is functioning, or I wouldn't be hearing anything. Alright, let's take a look at the Heathkit manual for the CR-1 crystal receiver. This is one that I printed and bound myself from a complete manual in PDF format that I downloaded from the internet. Has the usual Heathkit guide to capacitors, different methods of indicating their values, and on the inside of the back cover is a guide to common schematic symbols, many of them out of date today, but current at the time the manual was printed. So we have the front page, specifications, 540 to 1600 kilocycles, which we call kilohertz today. The primary tuning is a variable capacitor and switch with selected fixed capacitors. Secondary tuning is a variable capacitor. Has binding post for antenna, ground, and the headset. It weighs 1¼ pounds, and the rest is stuff we don't care about. This apparently did come with a set of earphones, and as near as I've been able to tell, they're not a Heathkit headphone set. It's some commercially available type that was quite popular, yet inexpensive at the time these came out. So here's the schematic. Remembering that for a crystal radio you need some basic things. You need your antenna, you need a tuning coil, you need a capacitance that's adjustable or fixed, depending. You have to be able to adjust either the coil or the capacitor or both, and then going to ground. Usually the capacitor and inductor are in parallel in a very simple minimalist type crystal radio. In this instance it's a little more complex circuit, so this particular adjustable capacitor is in series with the primary of the coil. It's like a little transformer, not just a simple coil. And so we have an adjustable capacitance for tuning only the antenna circuit. It's not tuning the whole radio. And if that turns out to not have enough span to get the desired stations, then you can turn a switch that adds in a 350 microfarad. That's what we call picofarads today. And if you turn the switch one more notch, it leaves that first capacitor in and adds another 350 picofarad capacitor, all in parallel with the original adjustable. So basically we have, a fair amount of capacitance values we can select through either by the switch and or by the knob on the antenna tuning capacitor. And then of course we've got our connection to earth ground. The detector side of the circuit is using a secondary coil with a tap. It's not a center tap, but a tap. And that has a capacitor across it, so this forms a resonance circuit of more the type we're used to with crystal radios. And the bottom side of that is connected to earth ground. The center tap, or the tap anyway, goes through our detector, which in this instance is simply a crystal diode. It's not a cat's whisker or anything like that. And then it goes to the headphones, which have to be high impedance, and then back to ground.
Hi, Raleigh. Would we order pizza?
No.
Okay.
Okay. So, what jockey has ridden the most Kentucky Derby horses in history?
Mike Smith.
Absolutely. And he beat out.
Right.
And he beat out whose record?
Ooh, I should know this.
Oh yes, you should, because he's one of the most famous jockeys ever.
Yeah, most famous shoe.
Yeah,
Shoemaker.
absolutely. Last rode, I think, in 86. He was the oldest, too.
He was, yeah, let me tell you about 86 and the old guys that year in sports itself. Jack Nicklaus was the oldest guy to win the Masters. And there was a couple other things he had too, but yeah.
I'm doing okay.
So we're going to do literature. All right.
Yes.
We will up-level the timbre of the show. All right, now for something. Which
continues into Thursday and Friday. We'll have a partly to mostly sunny sky. Thursday's high about 54. We'll get to 57 on Friday. I'm AccuWeather meteorologist Brian Thompson.
And now it's time for sports. Atlanta catcher Drake Baldwin and Oakland first baseman Nick Kurtz are baseball here. Six 5593 Myers-Briggs Trivia coming up on WGN Radio.
So this one's working much better than the other one. For some reason it's really touchy to things like this where the other one wasn't. There may be still a loose connection in there. I found a lot of things that are just screwed together weren't real tight on here, so I may just have a loose connection issue. I haven't restored this one yet. But I'm getting much better reception, more stations, much stronger signal.
To Contemporary, Mastercraft offers styles that fit every home. Shop the best in-stock selection of doors, or design your door your way in-store or online.
I should mention that it's almost midnight, so signals are a bit stronger.
Happening now. Climb with Tom Skilling to the top of a 100-foot tower in Rome.
And of course it's listenable with this pair of headphones, which came with this. The seller believed that these were the original headphones, and on another website, I can't remember which one off the top of my head, Jeff Tranter's probably, where he talks about his CR-1, and he believes that the radio originally came with a set of so-called Trimm headphones. That's a brand. So I tend to believe the seller, the Trimm ACME model high-impedance headphone, about 2,000 ohms DC, monaural. It's definitely listenable with this, of course, without the amplification of the powered speakers here. It's a lot fainter, but still it does work with these headphones. So that's a good thing. I believe this is the way these probably were originally done, with just the pin fittings on the ends of the wire. The alligator clips are awkward and they don't really fit the posts, so I suppose those are something that a previous owner just stuck on there. I didn't see them mentioned in the manual. Anyway, this is a pretty good functioning radio. I just need to give it a little cleanup.
Into my minding. INPP?
Absolutely. Now, there are other people who are voting for ENFP, but I do believe that that your answer is the most cited. So there you go.
Thank you.
All right, hang on. Don't go away. All right, so...
All right. Enough of that. There's a instrument description here, which is sort of a combination of basic radio theory and theory of the circuit of the radio receiver itself. And it's really written for kids or raw beginners. So it's actually pretty good in that regard. It mentions the temperamental cat's whisker and galena crystal type detector, and says, you know, we aren't even bothering with that here. We're just going to put in a germanium diode that requires no adjustment and is much more sensitive than the cat's whisker. And we're also using powdered iron cores or ferrite cores in the coil/transformer to improve efficiency and reduce the size of the coil. So you have a pretty narrow little coil like you might see inside an AM radio, a modern AM radio, not a great big coil like a normal crystal radio would have. Now you can't use like a steel core for this transformer because it wouldn't respond to radio frequency energy. That's why you need a either you need to use an air core or you need to use the ferrite core like this particular radio uses. The circuit description portion talks about how sensitivity is pretty much the most important part of this radio circuit. Selectivity is the ability of a radio to separate one radio station from another when they operate near the same frequency. Sensitivity is the ability of the radio to produce usable, or sensitivity, not selectivity, is the ability of the radio to produce usable volume from a weak signal. The circuit of the Heathkit crystal receiver was designed to provide the best possible combination of selectivity and sensitivity. And then they talk about, well, you're not going to be able to even discuss something like this without learning some new terminology, and it's going to be presented, you know, word or phrase one at a time as needed in the explanation. Talks about how the radio signals travel from the transmitting antenna to the receiving antenna in the form of the electromagnetic waves, or electrostatic waves I would have said, but anyway, when the waves pass the receiving antenna, they cause the electrical current to flow in the antenna circuit. Because of the nature of radio waves, the current that flows is an alternating current, AC, in other words, one that continuously reverses its direction of flow in the wire. And then they compare that to a game of catch, chucking a ball back and forth. It's not a bad analogy the way they develop it. It probably works adequately. In order to differentiate one radio signal from another that are all present at the antenna at the same time, it's necessary to select or tune the desired signal and reject the others. This is done using a resonant circuit. Two such circuits are used in the CR-1 crystal receiver. First one consists of the antenna, tuning capacitor, and a coil connected to it. In order to keep the tuning capacitor a reasonable physical size, a switch is used to switch in parallel capacitances as needed, primarily to match the type of antenna, not to expand the tunable range of the receiver. And again, that is because, at least in part, the antenna itself tends to have a fair amount of capacitance, and you need to take that into account when you're working out the entire circuit. The second resonant circuit consists of the detector, which is a tuning capacitor, and a coil, which is the secondary of the transformer made of the two coils. The combination of a coil and a capacitor is the ability to accept an alternating current of a certain frequency and preference to all other frequencies. By adjusting the electrical size of the coil or the capacitor, the resonant frequency may be adjusted to any desired value. And then they have some things you can build at home with springs and weights. And they say, well, you can, if you don't have a spring, you can use a rubber band and do some really basic stuff and kind of see how resonance works. And then you can have a string between two fixed objects and two rubber bands or springs, two weights, and you get one of them jiggling, and you'll see the other one always jiggles at the same frequency. So that's, you know, again, talking about the resonance of the circuit and how the primary and the secondary are coupled together. So, you know, they're doing a pretty good job with the analogies. And then they do talk about the purpose of the transformer in the radio. The electric current from the antenna flows through one of the coils. The antenna tuning capacitor tunes or resonates the circuit to the desired station. Since this is an alternating current, the moving magnetic field passes through the other coil, causing current to flow in it. This coil is tuned or resonated by the detector tuning capacitor. By providing two tuned or resonant circuits, the selectivity of the radio has been improved greatly. And then it talks about how you've got a voltage generated and how you have to convert it from a modulated signal to a demodulated signal, and it shows diagrams and provides analogies, which is actually pretty good. I just think their diagrams are a little too small. So almost 2 pages talking about that, and then finally how the resulting earphone circuit works. Now they show an electromagnet type of earphone, which suggests that the headphones they provided with the kit were a magnetic type. Still high impedance, but a magnetic type, not a piezo type. So we get out of that, so the theory of operations all up in the front. Proper soldering procedure, how to detect cold solder joints, mounting the banana binding posts, mounting the switch, one and one only wiring diagram, and really about a page of text between 2 pages explaining how to make all the connections. Then we talk about using the crystal receiver, how to rig up an antenna, you know, details of how to best tune it, a good procedure for doing so with the 2 different tuning capacitors. And then it's in case of difficulty, it's really basic, just recheck the wiring. Warranty shipping instructions if you have to send it back. Then there's the bill of material. And parts diagrams, and a chart where you can write down the settings, the antenna and the detector dial settings, and what the frequency would be, any call letters, etc. And that's the end of the manual.